Hello children, this is class 10 chapter 1 real numbers, and before we start with the class 10 portion, I'm just going to be revising with the number systems in this video. So let's start. Natural numbers. We also call natural numbers as counting numbers. That is, it helps us when we are talking about counting the number of items that we have. So one item, two items, three items, and so on. So we on the number line, this is the real number line. I have the numbers 1, 2, 3, 4, 5, and it goes infinitely in this direction. So this is the standard format in which mathematicians have always been writing for ages. So there are infinite number of natural numbers. The smallest natural number is 1, and you observe that there are no natural numbers between two natural numbers. So between 3 and 4 there is nothing in between. Now, when we add a 0 to the set of natural numbers, we are getting the set of whole numbers. And as you know, when we plot the points on the number line, you're going to always plot 0 to the left of 1. There are infinite number of whole numbers. 0 is the smallest whole number, and again there are no whole numbers between any two whole numbers. And also, very importantly, you know that every natural number is also a whole number. Integers. When we add the negative numbers to the positive or the set of whole numbers, positive numbers plus 0, that is a set of whole numbers. When I add negative numbers to the set of whole numbers, I get the integers. What was the necessity for having negative numbers? In order to understand that, suppose that this is the sea and you have a mountain over there. So if I consider the sea level as 0, anything above the sea level is considered as positive numbers. That is, you can have 200 feet above the sea level or 300 feet above the sea level, and in the same way I can have 200 feet below the sea level, which on the number line is represented as minus 200, or I can have minus 1200 and so on. So you can also see from that is these numbers, the negative and the positive numbers are represented on the number line. So there are infinite integers, which itself means that you cannot have a biggest integer, neither can you have the smallest integer. 0, remember 0 is neither negative nor positive. And there is no integer between any two integers. There are no integers between any two integers. Between this 1 and 2, between 4 and 5, between minus 3 and minus 2, there is no other integer between them. And every whole number or a natural number is also an integer. Now, having learned natural numbers, whole numbers, and integers, we are going to the next step, that is the set of rational numbers. In rational numbers, what we say is that any number that can be represented in the P by Q form, where P and Q belong to Z, that is integers, that is negative numbers, positive numbers, and 0, but Q should not be equal to 0. The denominator should not be equal to 0. All those numbers which can be represented in the P by Q form. So obviously over here we will have numbers like all the natural numbers, all the whole numbers, and all the integers. Why? Because when I'm saying natural numbers, that is, if I say 2, then 2 can be written as 2 by 1. In the same way, if I am saying, suppose I have a number over here that is 90, then I can write 90 as 90 by 1. That means all the natural numbers can be written in the P by Q form. In the same way, whole numbers, that is adding 0, if I look at 0, 0 can be written as 0 upon 1. That means this is also 0 will also become a rational number. And similarly for the negative numbers, because I can write them as minus 3 by 1, minus 4 by 1. In the same way, if I have a number right over here that is suppose equal to minus 99, then I can write it as minus 99 divided by 1. So the only condition being that my denominator should not be equal to 0. So as long as I satisfy these conditions, then I will say that all the natural numbers, all the whole numbers and all the integers will be rational numbers. Now let us understand a little more, that is the representation of rational numbers on the number line. So I am taking this number line and suppose I am taking the point between 2 and 3. So if I divide the unit distance between 2 and 3 into two parts, then this is going to be 2.5, that is equal to 5 by 2. And if I divide the distance between 2 and 3 into 20 parts, then the first part is going to be equal to 1 by 20, or it is actually going to be equal to 2 plus 1 by 20, because this is already 2 plus 1 by 20. So I am going to have over here 2 plus 1 by 20. In the same way, if I'm looking at the last part over here, this is going to be 19 by 20. So I will say this point will be equal to 2 plus 19 by 20, and this part will be equal to 2 plus 1 by 20. Same way, just suppose that I am now going to divide this 2 by 3 in, suppose I divide it into 100 parts. That means 1, 2, 3, 4, and it goes up to here, suppose. So which means this part is going to be equal to 2 by 100, that is this part will be 2 plus 2 by 100. And suppose I look at this part, that is the third part from 3 towards the left, then this is going to be 97. Therefore, this point is going to be 2 plus 97 by 100. That is, if I am dividing it into 20 parts, then I'm going to look at it as first part as 1 by 20 and the last part will be equal to 19 by 20. In the same way over here, this is the second part is going to be 2 by 100, or if I have divided it into 100 parts. So which also tells you that between any two numbers, there are infinite number of rational numbers. So it all depends upon how many parts I am dividing it into. If I divide it into 20 parts, I am getting 20 rational numbers in between. If I divide it into 100 parts, I'm going to get 100 rational numbers in between. If I divide it into 1000 parts, I'll get 1000 rational numbers in between. Okay. So when I'm talking about rational numbers, the condition will be that any number that can be represented in the P by Q form, where P and Q are integers and Q is not equal to 0, is called a rational number. That means there are infinite number of rational numbers, because there are many small numbers, big numbers. You don't know which is the smallest rational number. There is no biggest rational number also. Every natural number will be a rational number. Every whole number, every integer can be represented in the P by Q form, and therefore all these are rational numbers, like I had explained to you in my previous slide. There are infinite rational numbers between any two rational numbers. This is what I had explained in the previous slide. That is, if I divide it into 100 parts, I can get 100 rational numbers. If I divide it into 1000 parts, I can get 1000 rational numbers. And also, you must understand that rational numbers are either terminating or recurring decimals. Recurring numbers. I will explain this to you even further. Understand that every rational number is either terminating or a recurring number. So the irrational numbers are those numbers that cannot be represented in the P by Q form cannot be represented. So when you look at these numbers, you see 5 by 10 is 0.5. It is a terminating number. 21 by 2 is terminating. This is also terminating. In these ones, you observe that 428571 and again 428571. So there is a repetition of 428571. In this one 3 by 13, 0.230769, 230769, which is these numbers are repeating, these digits are repeating. And 22 by 7 you have 3.142857 and again 142 dot dot dot. You observe these numbers are the recurring numbers. But when I look at these numbers, you see that I cannot predict what my next digit is going to be. Next decimal value is going to be 0.31825. I don't know what my next digit is going to be. Here 01001 0. You see the decimal value is unpredictable. So root 2, root 3, pi, these are all irrational numbers. So those numbers which are neither terminating nor recurring become the irrational numbers. So in the previous slide we had done that all numbers which are terminating and non or recurring are called rational numbers, and those numbers which are neither terminating nor recurring will become the irrational numbers. So the representation of irrational numbers root 2 on the number line would be like this. That is, you are taking a number line and this is suppose unit length. You call this as unit length and this is a right angle triangle. So the hypotenuse becomes OA square plus AB square, that is equal to 1 square plus 1 square, which is equal to root 2. So when I put my pointer here and take this much distance and I draw an arc like this, since this distance is equal to root 2, this is the circle. So that means this is also going to be equal to root 2, which implies that this point P represents root 2 on the number line, which is an irrational number. So the set of rational and irrational numbers is together becoming the set of real numbers. Obviously, there are infinite real numbers. All numbers which are either recurring and non-recurring, terminating, non-terminating become real numbers. And very importantly, between two real numbers, there are infinite real numbers. You have learnt all this in class 9. And this is very important for your class 10 too. So let's start with the actual class 10 syllabus, that is the Euclid's division lemma, which will be the next video.